What is a decay factor? A decay factor helps you calculate, in one step, a final amount after a percentage has been subtracted. Using a decay factor is incredibly useful when you need to calculate a percentage decrease, and it saves you a lot of time. Decay factor, often abbreviated DF, is given by this formula. Decay factor equals 1 minus r. The minus sign tells you there is a decrease. The variable r is a decimal representation of the percentage that is being subtracted. You find r by dividing the percentage, p, by 100. r is known as the rate of decay. Let's take a deeper look. It's convenient to think about the decay factor like this. The decay factor tells you how much of the initial amount you were left with after the amount decreases. Let's look at an example, first solving it without using a decay factor, and afterwards using a calculation with a decay factor. Say a clothing store sells a jacket with an initial price of $200, but there will be a sale once the summer is over, when the price will decrease by 14%. So you want to find the price of the jacket after summer. Your old method would look like this. First, you find the decrease. 200 times 14 divided by 100. 200 is 2 times 100, so you can cancel out 100 in the numerator and denominator, leaving 2 times 14, which is 28. Then you subtract this decrease, 28, from the initial amount, 200, which equals 172. The price of the jacket after summer will be 172. Now let's see how you can do it all in one step by creating a decay factor expression. Combining the two original steps, the initial price minus the percentage decrease, gives you the opportunity to factor out the price, leaving you with a very elegant formula. Let's see how. Notice that the price 200 is in both terms, which means you can factor it out. This gives you 200 multiplied by the quantity 1 minus 14 over 100. 14 over 100 is the same as 0.14 in decimals. So you get 200 times the quantity 1 minus 0.14. Do you notice the resemblance? If you ignore the 200, you're left with 1 minus 0.14. This is the decay factor, 1 minus r, but you have inserted 0.14 for r. This factorization works for all situations where you want to subtract a percentage from the initial amount. So you can always use the one-step formula with a decay factor to find the final amount. You just multiply the initial amount by the quantity 1 minus r. There really is no reason to do two operations when you can learn to use the decay factor formula and take care of it all at once. Now let's finish the calculation. 1 minus 0.14 equals 0.86. The initial amount 200 times the decay factor 0.86 gives you the final amount, 172. The price of the jacket will be 172 after the summer. Now, let's recap how the decay factor works. Using the first method, without a growth factor, you first find the percentage decrease, then subtract that decrease from the initial amount. In the decay factor formula, the two steps are collected into one. The first term, 1, is a percentage representation of the initial amount from the first calculation, since 1 is equivalent to 100%. The variable r represents the percentage decrease that is being subtracted from the second calculation. The fantastic property of decay factors is that just like growth factors, they actually combine two calculations into one. This saves you a lot of time and energy, Plus, it's pretty simple. A decay factor helps you calculate, in one step, a final amount after a percentage has been subtracted.